For decades, interacting with a computer meant dealing in absolutes. If you wrote a specific line of code, the machine executed a specific, predictable action. Software was governed by strict if-then logic, demanding absolute determinism from the system. But large language models operate on a completely different architecture. They don't actually read words. They process text as tokens, segmented blocks of characters. To generate a response, the system plays a complex game of probability, calculating which token is mathematically most likely to come next. Once the most probable piece locks in, the machine recalculates the odds for the one after that. This probabilistic engine makes AI exceptionally good at creative tasks like writing a poem or drafting an email. The variance creates natural-sounding text. However, that exact same variance becomes a massive liability when you need strict factual accuracy. Imagine deploying an AI to audit thousands of pages of financial compliance records. If the system relies on a statistical guess rather than an absolute rule to determine tax liabilities, a single high-probability error could cost a company millions in penalties. To use non-deterministic systems in high-stakes environments, engineers must proactively build boundaries that force a chaotic probability engine to behave reliably. Let's look at how we build those boundaries, starting with a common enterprise scenario, an automated system designed to scan global supply chain contracts for legal vulnerabilities. The most basic way to interact with an AI is through zero-shot prompting. This involves handing the model a raw contract and asking if the document contains risks, without providing any prior examples or rules. This diagram of the system's token selection illustrates the danger. Because the prompt is unconstrained, the model might suffer from confabulation. It literally invents a fake legal precedent, citing a court case that never existed, simply because that sequence had the highest probability of occurring next. Engineers use few-shot prompting, feeding the system examples of safe and risky clauses. A standard contract matches the pattern and is correctly flagged risky, but a completely novel contract finds no exact match. The pattern breaks, and the model reverts to an incorrect probabilistic guess. Relying on simple pattern matching fails when the logic gets complicated. To truly control the output, we have to constrain how the machine processes information, rather than just filtering what it outputs. This requires a technique called chain of thought constraint. Instead of demanding an immediate final answer, we instruct the model to execute a sequential series of logical steps before it is allowed to reach a conclusion. This flowchart maps the engineered cognitive pathway. First, the system must extract dates and isolate regional stability factors. Only then does it expand to calculate financial exposure using that specific data. By forcing this sequence, the complex contract systematically reaches the correct risk determination. Because the AI is explaining its work at every stage, human engineers can review the exact logic trail. If an error does occur, we know precisely which step in the chain failed. We've taken a system built entirely on unpredictable probability and boxed it in with a strict sequence of thoughts, effectively forcing a reliable, deterministic result. As AI moves into the modern enterprise, the focus is shifting away from writing clever text. It's becoming a discipline of architecture, designing the structures that keep a probabilistic model on track. Traditional development meant coding exact steps for a machine to execute. Today, we are learning to program with context and constraints, building the environment that makes a guess reliable. This requires a new skill set, the ability to map out the guardrails and boundaries that turn raw computing power into a predictable tool. The mastery of this technology doesn't come from the words we type into a chat box, but from the logical scaffolding we build